Let's move on to the dependent events. Two events are dependent if the occurrence of one event is affecting the probability of another event. If two events are A and B are dependent, then the probability of both events occurring is the product of probability of A and the probability of B after A occurs. In symbols, P, the quantity of A and B, is equal to PA multiplied by PB after A. Here is example number 1. A box contains 5 strawberry candies, 7 chocolate candies, and 3 mint candies. Janice randomly chooses a candy, eats it, and then randomly chooses another candy. What is the probability that Janice chose a strawberry candy and then a mint candy? So for the solution, let A be the event that the first candy chosen is strawberry, and then let B be the event that the second candy chosen is mint. So the probability of choosing a strawberry candy is 5/15 or 1/3, and the probability of choosing a mint candy is 3/14. So let's use the formula PA and B is equal to PA multiplied by PB after A. So PA and B is equal to 1/3 multiplied by 3/14, and the product would be 1/14. Therefore, the probability that Janice chose a strawberry candy and then a mint candy is 1/14. Moving on, here is example number 2. A basket of fruits contains 4 oranges, 5 guavas, and 4 mangoes. 2 friends came to their house and each of them were given fruits. What is the probability that the fruits given is guava and mango? So for the solution, let A be the event that the first fruit chosen is guava, and then let B be the event that the second fruit chosen is mango. So for the probability of a guava given is 5/3, and then the probability of a mango given is 4/12 or 1/3. So let's use the same formula. PA and B is equivalent to PA multiplied by PB after A. So P, guava and mango is equal to 5/13 multiplied by 4/12. Then P, guava and mango is equivalent to 5/13 multiplied by 1/3. So the product would be 5/39. So therefore, the probability that a guava and a mango fruit is given is 5/39.
For our first example, we will have this problem. Mr. Prietti needs 2 students to help him with a science demonstration for his class of 18 girls and 12 boys. He randomly chooses 1 student who comes to the front of the room. He then chooses a second student from those still seated. What is the probability that both students chosen are girls? You can pause the video to try and answer it yourself. To solve this problem, let A be the event of selecting the first girl while B represent the second chosen girl. After that, we will have to find the separate probabilities of each event. Always remember that in getting the probability of an event, it follows the order of n quantity A all over n quantity S, or the number of event A all over the total sample space. For the first event, we will have the probability of 18/30 since there are 18 female students and there are 30 students in total. For the second event, however, you'll notice that both numerators and denominators have decreased by 1. This happens because in the first event, we've already called the first girl and therefore decreasing the number of girls and the total number of students by 1. Hence, the probability of event B is 17/29. Now that we have both separate probabilities, we can now follow the formula probability of A and B is equal to probability of A multiplied by the probability of B taken after A. Substituting the values above, we now have the probability of A and B is equal to 18 over 30 multiplied by 17 over 29, which gives us the product of 306 all over 870 or 51 over 145 rather when simplified. Therefore, the probability of choosing both girls is 51 over 145. The second example problem that we need to solve is 4 cards are chosen at random from a 52 deck of cards without replacement. What is the probability of choosing a 10, a 9, an 8, and a 7 in order? Just like the first problem, you can pause the video to solve it yourself. In solving this problem, we will have to get our representations, which are A be the event of getting a 10, B is the event of getting a 9, C is the event of getting an 8, and D is the event of getting a 7. Then, we'll have to get the separate probability of each event, so we have a probability of A being 4 over 52 because there are 4 10 cards in a deck, and 52 cards in total. Since the problem specified that the selection of cards is without replacement, the events following A are dependent and will have a different number of sample spaces. So we have the probability of B being 4 over 51 since there are 4 9 cards in a deck and 51 as our sample space since we've already drawn a card from event A. Probability of C is equal to 4 over 50 as there are 4 8 cards in a deck and 50 as our sample space since we've already drawn 2 cards from the previous events A and B. Lastly, the probability of event D is 4 over 49 since there are 4 7 cards in a deck and 49 as our sample space because we've already drawn 3 cards from the previous events. Now that we have the separate probabilities of each event, we can now solve for the question being asked. Substituting the values above, we have a probability intersection of the events is equal to 4 over 52 multiplied by 4 over 51 multiplied by 4 over 50 multiplied by 4 over 59, which gives us 246 all over 6,497,400 or 32 all over 812,175 when simplified. Therefore, the probability of drawing a 10, a 9, an 8, and a 7 in order is 32 all over 812,175. For the last example, we will have this problem. You randomly select 2 marbles from a bag that contains 14 green, 7 blue, and 9 red marbles. What is the probability that the first marble being selected is blue and the second marble is not blue if A. You replace the first marble before selecting the second, and B. You do not replace the first marble? Again, you may pause the video and try to answer it yourself as practice. Before anything else, let us set our representations. Let A be the event of getting the first blue marble and B as the event of getting the second marble that is not blue. For question A, the formula we will use is one used in independent events as it has been stated that the first marble is replaced before drawing the second. So, the probability of A and B is equal to 7 over 30 times 23 over 30 since there are 30 marbles in total. There are 7 blue marbles as stated, and logically there are 23 marbles that are not blue. Simplifying the equation, we now have 161 over 900. Therefore, the probability of getting a blue in the first marble and getting a marble who's not blue in the second with replacement is 161 over 900. Now for question B, the formula we will use is one used for dependent events since it was stated that the marble is not replaced this time. So, the probability of A and B is equal to 7 over 30 since there are 7 blue marbles and 30 marbles in total. Multiplied by 23 over 29 since there are 23 marbles that are not blue and 29 as sample space because we've already drawn the first marble in event A. Simplifying the equation, we have the probability of A and B being equal to 161 over 870. Therefore, the probability of getting a blue in the first marble and getting a marble who's not blue in the second without replacement is 161 over 870.
So for the key points, here are the things you need to remember. First, two events are independent if the occurrence of one of the events is not affected by the occurrence of the other event. Second, if two events A and B are independent, then the probability of both events occurring is the product of probability of A and B. In symbols, p-value of A and B is equal to p multiplied by A times p multiplied by B, or p-value of A intersection B is equal to p multiplied by A times p multiplied by B. Third, two events are dependent if the occurrence of one event affects the occurrence of the other. Fourth, if two events are A and B are dependent, then the probability of both events occurring is the product of the probability of A and the probability of B after A occurs. In symbols, p-value of A and B is equal to p multiplied by A times p multiplied by B divided by A, or p-value of A intersection B is equal to p multiplied by A times p multiplied by B divided by A. That's all for today. Thanks for watching. We hope that you clearly understand the lesson. But before we end the video, we are going to give you two problems for you to solve, and it will be your assignment. So the first problem is flashed on the screen. We're giving you 5 seconds to screenshot or pause the video. So here's the second problem. So that's all. So just pass the assignments on our GC or PM. So that's all. Thank you. Bye.